Let's factor 3x squared minus x minus 4 using our grouping technique. So to start out with, recognize that in our example, our a is the coefficient on x squared, so it is 3. Our b should be the coefficient on x. Now I wrote negative x. Remember, that means negative 1x. So my b is negative 1. And then the next thing I have is c, which is negative 4. So I'm going to compute a times c first. That's my step 1. I always do this over here on the side. I write a little vertical line, at least while I have all the spaces written out here. So ac is going to be 3 times negative 4, or negative 12. So I need to find factors of negative 12. Okay, well, one of those factors would be 3 and negative 4. I also could have 2 and negative 6. I also could have 1 and 12. And then negative 12. And in each of these cases, I could also have it where the opposite, the other term was the negative term. So we could have negative 3 and 4. Negative 2 and 6, and negative 1 and 12. Now, similarly to my goal when we were doing the single coefficient of 1 on the x squared term, my goal is to get it so that the coefficients add to that negative, or the term in the coefficient on the x term. So I'm looking to add to, I don't know why I wrote negative 4 there, negative 1. Which of these pairs adds to negative 1? Oh, well, that would be 3 and negative 4. 3 plus negative 4 is negative 1. So I know that I'm going to split the polynomial up into, instead of writing negative x, I'm going to write 3x plus negative 4x. So I'm going to rewrite it as 3x squared plus 3x plus negative 4x minus 4. You could choose to just write this as minus here. I think sometimes it's easier, though, to leave the coefficient, the negative coefficient, on the term. Now, you may be asking yourself, why did I do the 3 first and then the negative 4? I'm looking, and I know, notice I wrote here, I want q to have a common factor with the last term. I know the last term is just a constant. So when I split p and q, if only one of them happens to be multiple, or have a common factor with the constant term, then q should be that one. So I picked negative 4 for my q and wrote the negative 4x last, because I noticed that means that these last two terms have a common factor. So when you're doing these steps in real life, you might choose not to have sort of a separate line for each of these, but I'm going to do that here just to make it real clear, okay? So first, we're going to look at the group of the first two terms, the 3x squared plus 3x. So 3x squared plus 3x. I'm looking for the greatest common factor, the GCF of these. I notice that both terms have a 3 in them, and both terms also are a multiple of x. So I'm going to rewrite 3x squared as 3x times, what else would I need to get the first term x squared? Well, I would need another x. Plus, what do I multiply 3x by to get 3x itself? Oh, I just multiplied by 3x. I just multiplied by 1, sorry. So the other term is a 1. All right, now let's do the last two terms. Our last two terms are negative 4x minus 4. What is the number that they have in common? Well, both of them are multiples of negative 4. Negative 4x is negative 4 times x, and negative 4 is negative 4 times 1. Look for ones, they show up a lot. All right, let's now stuff these pieces in. The first two portions here, these are my factoring of the first two terms. And as I said before, you might just do steps 4 and 5 as one line. So we factored out a 3x in front of an x, 1x plus 1, if you will. I'm just going to scribble that all out and just let it be x plus 1. And then the second one, I had -4. Again, it was 1x plus 1, so just x plus 1 in this case. Now I look at my two pieces. We are in step 6. I'm going to circle the common factor in the two chunks and the largest common factor that I can find. So, I notice here both chunks have an x plus 1. Almost always this is going to be the case where it'll be that whole other portion if you set this up right. All right, so one of my two factors therefore is x plus 1. If I factor that x plus 1 out of both terms, what remains? Well, in the first term, I'm left with I need a new color, 3x. So the first term was 3x times x plus 1. And in the second term, I'm left with a -4 because I had -4 times x plus 1 in the second term. So at the end of the day, we get that our polynomial 3x squared minus x minus 4 can be rewritten as 3x minus 4 times x plus 1. Let's quickly check and make sure it FOILs out right. So 3x times x, that's my firsts. All right, then I'm going to add the outside terms. So 3x times 1, which is 3x. And then I'm going to multiply the insides, -4 times x, so minus 4x. And lastly, I'm going to multiply the last two terms. And that would be -4 times 1. No one can see that. -4 times 1, and I would get a -4. So now you can see when I combine my two terms, notice it's split back to exactly what I had before. I do get 3x squared minus x minus 4. And so that's my check that I did, in fact, find the right product.